So yesterday we said trigonometry is the study of triangles. On our course, we're only dealing with right triangles or right angle triangles. In a right angle triangle, the long side is always called the hypotenuse. The other two sides may have a name, but it depends on which angle we're talking about. So they may be called adjacent or they may be called opposite, but it depends on the angle. Pythagoras' theorem says b squared plus c squared is equal to a squared, or the square on the hypotenuse is the sum of the square on the other two sides. I think it's easy to do that maybe without the algebra if you can. Similar triangles have the same angles, and they also, as well as having the same angles, they have a ratio between the sides. So that two corresponding sides will always have the same ratio. So in this example here, where the ratio from there to there is multiplied by 2, the same thing with the ratio to here will be multiplied by 2. Or put differently, 3 divided by 5 over 5.5 would give you the same answer as 6 divided by 11, that they're in the same ratio, the sides. Then we used this to form these trigonometric ratios. And this is the most important thing we did yesterday, was that SOHCAHTOA is a way to remember these particular fractions. So the fraction for sine of an angle is the fraction of the opposite side divided by the hypotenuse. The cosine of an angle is adjacent divided by hypotenuse, and tan of an angle is opposite divided by adjacent. Last night, I gave you this question to do for homework. Everyone with me still? Okay. Yeah. Okay. Yeah. So I'm going to quickly answer these questions. First was to work out the side, the length of x. We use Pythagoras Theorem for this. So I'm going to work out the square on 12. 12 12s are 144. The square on 5. 5 5s is 25. The square on the hypotenuse is you add these together. 144 and 25 is 169. So x is equal to the square root of 169, and the square root of 169 is equal to 13. So the answer was x is equal to 13.
Sir, Shauna couldn't join because her Wi-Fi.
I'll just record it, and sure we'll get her to join in after. She can look at it afterwards. That's all I can do. Okay, but thank you for letting me know. In the second part of the question, it's asking me what, compared to angle A, it's asking for the sine, cosine, and tan. So let's remind ourselves of the phrase again to remember this. The phrase is SOHCAHTOA. So sine ratio is the opposite divided by the hypotenuse. Now, it depends on which angle we're talking about, though. So when we're talking about angle A, in angle A, the opposite in angle A, the one across from it, is 5. So in angle A, the opposite is going to be 5. So the opposite in this first question is going to be 5. The hypotenuse, I suppose it doesn't change. The hypotenuse is going to be 13 in each of these questions. So the hypotenuse is always going to be 13. And compared to A, the one adjacent, which is beside A, which is not the hypotenuse, is going to be, I'm using this color here, is 12. So if we're talking about angle A, well then sine A is opposite over hypotenuse, which is 5 over 13. Cosine A is adjacent over hypotenuse, which is 12 over 13. And tan A is opposite over adjacent, which is 5 over 12. Now, I know some people had asked me on Teams, they were just a bit confused about what's going on with angle B. So with angle B, the thing changes around. So I have to do something slightly different with angle B. So if I'm talking about angle B, we'll leave these. Compared to angle B, the opposite actually this time is 12. So I'm talking about angle B, that's what your opposite is. And your adjacent becomes 5. So I'm going to write out our SOHCAHTOA rules again. So if I'm talking about angle B, which I'm talking about in this question here, now I have to change around what I'm talking about. So compared to B, the opposite this time is 12. The hypotenuse doesn't change. That's still going to be 13. And the adjacent is 5. So if I'm talking about angle B, sine of B is opposite over hypotenuse, which is 12 over 5. Sorry, I'm saying that backwards. Opposite over hypotenuse, which is 12 over 13. Cosine B is 5 over 13, adjacent over hypotenuse, adjacent to B. And tan B is opposite to B, which is 12 divided by adjacent to B, which is 5. So we'll notice what's after going on here is we're kind of, these are switch places. You'll notice the switching around here. In trigonometry is the theorem of Pythagoras, which we have covered already a little bit. So I think this theorem is covered already. So I'm going to quickly, just to cover the questions in the book, I'm going to quickly just do these examples for you. So in the first one, Pythagoras says the square on this side, 6 sixes are 36. The square on this side, 8 eighths are 64. That if I add those together, 36 and 64, which is 100, it gives me this, the other side. So the square root of 100, which is equal to 10. So x is equal to 10. That's the first example. Then chapter 2, section 2 is about sine, cosine, and tangent ratios. Now this is what I introduced yesterday. The main thing to remember here is the phrase. The main thing on sine, I'm going to write this really big. The main thing to remember is SOHCAHTOA. Okay? And what this means, that sine of an angle is the opposite side divided by hypotenuse. That's the ratio. The cosine of an angle is adjacent divided by hypotenuse, and the tan of an angle is the opposite divided by the adjacent. That's the most important thing that we learn here. Now, this is a new type of question, so I want you to watch what's going on here. This example is different than we met yesterday. Okay. It says tan B is the square root of 5 over 2, and we're to find the value of sine B and cosine B. How you do a question like this is, first thing is draw a right angle triangle. So this is the first step, and draw any one. It doesn't have to be to scale. So I'm going to draw a right angle triangle. So there's a right angle triangle. So that's the first step. I'm going to call one of the angles in this angle B, because that's what it's calling here. It's talking about tan B. Well, what does tan mean? What does tan B mean? Someone tell me. What does tan B mean?
Tangent?
It does. In terms of the ratio though, in terms of my formula, what do these numbers root 5 over 2 mean, do you think? What does tan mean?
Opposite divided by adjacent.
That's exactly what it means. So I'm going to have to label my sides. So I'm going to label sides in this triangle. So this is the next step. I'm going to label them O, H, and A. Well, the long side is the hypotenuse. Opposite to B is the one over here. It's across from B. And beside B is here. So I'm going to label my three sides, O, H, and A. Now we know two of these sides. Which ones do we know? We know that the opposite, that when it tells me that tan B is equal to root 5 over 2, what it's telling me here is that the opposite over the adjacent is root 5 over 2. So I can label the opposite side root 5, and I can label the adjacent side as 2. Okay. To find sine and cos I'm going to have to know what the hypotenuse is. How could I find a hypotenuse here? Using Pythagoras Theorem, we could work out what the hypotenuse is. So we want the square on the two small sides added together will be equal to the square on the hypotenuse. So firstly, if we square 2, we get 4. And if we square root 5 by root 5 will give us 5. So we add 4 and 5 together to give us 9. And the square root of 9 is 3. So the hypotenuse must be equal to 3. So now I can answer the other questions. So what is the formula, if I'm asked the question, what is sine of the angle B? So using the rule here, sine is opposite over hypotenuse. So what is the fraction or the ratio for sine B?
5/9.
Root 5 over 9 is correct. And what's the ratio for cosine of B?
4/9.
That's the right answer, 4 over 9. Okay. So this is an important example. So remember the steps that we did here. Firstly, I drew the triangle. I labeled the sides and called one of the angles, called an angle B and labeled the sides compared to B. I put in the information I knew on the picture. Using Pythagoras, because I knew two sides, I could work out the other side. And then that I had all three sides, but I could easily write down what the other ratios were. Okay.